All right, lesson 98, the sum of angle measures of triangles and quadrilaterals. So, as always, let's start it out with some vocabulary. Exterior and exterior angle. So the word exterior, ex, means exit, outside. So exterior means outside. An exterior angle is an angle on the outside of a polygon. Interior means inside. So an interior angle is an angle inside of a polygon. And I just drew a little quadrilateral parallelogram guy right there. And I labeled interior on the inside. And then all this stuff on the outside, anything out here, 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 is exterior. Right here, I have a triangle. And I labeled 40 degrees and 50 degrees, and my little right angle. So 40 is an interior angle, 50 is an interior angle. But if I draw a little dotted line that comes out from this leg and comes out, 130 degrees would be an exterior angle. So interior, inside, exterior, exits to the outside. Interior and exterior angles. So now we're going to actually talk about the new concept. If we draw a polygon, so a multi-sided shape, and make the line keep going from a corner or a vertex, we will form an exterior angle. If we add up the measurement of the exterior angle and the interior angle it touches, they equal 180 degrees. So they are supplementary, as defined on Monday in lesson 71. So here's my polygon. It's got 4 sides on it. Interior angle, exterior angle. And if I take this line right here, and I just keep on extending it out past the angle right here, I'm going to get an interior angle and an exterior angle. And they're going to add up to 180 degrees. Which, if I take my protractor again, put it right there in the vertex. Starts here, 0, goes all the way around until I get my 180 degrees. Or, right here, I'm at about 125 degrees. And then that 125 plus 0 up to, right there, about 55. 125 plus 55 makes 180. Angle 1 is interior, angle 1 is that one, it's exterior. Angle 2 is interior. So the sum, or the total when you add, the sum of exterior angles of triangles and quadrilaterals is what we're going to talk about. So if you add the exterior angle measurements around any polygon, it equals 360 degrees. Why? Because a full circle has 360 degrees, or you would need to make 4 90 degrees turn to turn completely around. So if I start here, and I want to get back to facing this way, I would go 90, 180, so now I'm completely turned around, 270, 360, gets me back to where I started. And my Wriggle Pro tip, air horns. You can remember that 360 degrees is a full turnaround because that's how we would pwn a noob in Fortnite, if I played it. Hashtag 360 no scope, whoop whoop. You know, the move where you're facing forward and then all of a sudden you go, boom! 360 no scope without any assistance. Because I'm just that good. Alright, so 360 is a complete circle all the way around. The sum of exterior angles continued. So if I have this shape right here, it's a triangle, and I extend the lines, so I extend this line, then I'm going to extend this line, and I'm going to extend that line. Now I'm going to label each of the angles 1, 2, and 3, starting from wherever I want. The sum of the angle measures for 1, 2, and 3 is 360 degrees. In other math, measure of angle 1 plus measure of angle 2 plus the measure of angle 3 equals 360 degrees. So if I do the same thing with the quadrilateral, and I make all my shapes, I extend, I extend, I extend, I extend, label 1, 2, 3, 4. Just make sure you're always staying consistent about how you are extending and which side you're labeling. So the sum of the measures of angles 1, 2, 3, and 4 is 360. In other math, measure of angle 1 plus measure of angle 2 plus measure of angle 3 plus measure of angle 4 equals 360 degrees. So the average exterior angle. To find the average measurement of each external angle, divide 360 degrees, your full circle, by how many turns or corners? So this one we would divide by 3, this one we would divide by 4. So the average external angle of a triangle is 360 degrees divided by 3 turns, 3 angles. If I reduce that, it becomes 120 over 1, which is 120 degrees. The average external angle of a quadrilateral is 360 degrees divided by 4, and I'm using prime factorization, kind of-ish. 2 times 2 times 90 would give me 36, or 360, because 4 times 9 makes 36, add a 10 on there. 4 is 2 times 2. Then I can cancel out my 2's, and I just come up with 90. So I can either divide each of these by 4, or I can divide by those 2's, however you want to do it. Just make sure you get 90 when you're done. The sum of interior angles. The sum of interior angles depends on the type of polygon, and it will get larger as the number of angles increases. The sum of interior angles of a triangle is 180 degrees. 1, 2, 3, if I label each of those, then the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 gives me 180 degrees total. So this is one reason why on that big triangle project I asked you guys to measure each of your angles, because if you had done that correctly and labeled them with your protractor and actually gone through, you probably would have noticed that every single triangle you made, you could add up the corners to make 180 degrees. The sum of interior angles of a quadrilateral is 360 degrees. So angle 5, 6, 7, and 8, measure of angle 5 plus measure of angle 6 plus measure of angle 7 plus measure of angle 8 equals 360 degrees. So my pattern, 180 degrees, I add one angle, it doubles. What do you think it would be if I had 5 angles? Just add 180 to 360, and it should be 540. Okay, so finding a missing angle. If you're given an exterior angle, you can solve for its adjacent, touching next to it, interior angle. Use 180 degrees because of our supplementary definition, minus the measure of the external angle equals the measure of the internal angle. So if I have this polygon here, A, it's a hexagon, and I have an external angle of 70 degrees, and it's touching angle A, how would I solve for A? Well, I know I have a big straight line right here, so that line is 180 degrees, and if I subtract 70, I'm left with the answer for A. So 180 degrees minus 70 degrees equals 110 degrees. So angle A would be 110. Not too bad. If you are given most of the interior angles, but one is missing, you can use the sum of interior angles to solve for the missing angle. So example 1, find angle A, or find the measure of angle A in triangle ABC. So I'm making a note that M with a blank angle sign and an angle with that little arc through it both mean the measurement of an angle. So if you just see angle by itself, that's saying I'm calling this angle A, B, or C. I'm not talking anything about numbers yet. As soon as I put that M on there, or that little curve through it, that means I need to know how big that angle is. Okay, so measure of angle A plus measure of angle B plus measure of angle C equals 180. I know this because the sum of the interior angles of a triangle add up to 180 degrees. And my angles are called A, B, C in this case. So now, measure of angle A is the one we don't know, so I'm going to keep measure of angle A. Measure of angle B is actually 60, so I'm going to write the number 60 instead. Measure of angle C is 70, so I'm going to write the number 70 instead, and then equals 180. Measure of angle A, I still don't know it, so I'm going to write it down again. 60 plus 70 equals 130. 6 plus 7 is 6, 7, 8, 9, 10, 11, 12, 13. My zeros still stay. So 130 equals 180. So what number plus 130 equals 180? These are pretty easy. You might be capable of doing it in your head, doing mental math, but please try to make sure to show every single step. This is going to prepare you for when you're actually doing algebra in the future. Next year, future. So 130 plus A. A is not by itself. I have to get A by itself. Right now there's a plus sign. I'm going to use my inverse operation of subtracting. I'm going to subtract 130 degrees from both sides. So 130 minus 130 equals 0. 180 degrees minus 130 degrees equals 50 degrees. So this is now gone, it's canceled out. So I have A, measure of angle A, equals 50 degrees. So I'm going to write it as angle A equals 50 degrees, or measure of angle A equals 50 degrees. And example number 2, I want to find this missing angle right here in the quadrilateral QRST. So I'm going to use my memorized number, 360 degrees, equals the sum of all the angles in that quadrilateral. Angle Q is 80, so I'm going to write it as 80. Angle R is 80, so I'm going to write it as 80. Angle S, we're told, is 110, so I'm going to write that in for S. Angle T, that's the one we're still trying to figure out, so that one has to stay measure of angle T. And equals 360 degrees, because remember, that is still the sum of all the angles together. So now I'm going to combine these additions. So 80 plus 80 plus 110. 80 plus 80 is 160. 160 plus 110 is 270. So I have 270 degrees plus measure of angle T, I still don't know that, equals 360 degrees. Angle T is not by itself, but I want to make it that way. So I have to use my inverse operation. I have an addition, so I'm going to subtract. 270 minus 270 equals 0. 360 minus 270 equals 90. So this is gone now, and I just have angle T equals 360 minus 270, or angle T equals 90. So angle T equals 90. Or M angle T equals 90 degrees. And that's all you need to do. If you need some more help on this, go ahead and find me on Zoom. You know how to do it. Thanks, guys. Good luck.